A scientific calculator follows the keys you press, not the idea in your head. Enter 3 plus 4 divided by 2, and the calculator divides first, producing 5. Enter the quantity 3 plus 4 divided by 2, and the parentheses force the sum first, producing 3.5. Every number is the same, but the entries describe different structures. Parentheses are not decoration. They are instructions that protect a group. Today, we will translate written mathematics into keys that preserve exactly what the expression means. 4 calculator habits prevent most entry errors. Use parentheses to protect complete groups. Use an explicit multiplication key when a number sits beside parentheses. Use the power key only after identifying the complete base. Use the square root template so the full radicand stays under the radical. Before pressing enter, scan the display from left to right and match every opening parenthesis with a closing one. The calculator can execute order of operations perfectly, but only for the expression that actually appears on its screen. Translate the fraction 12 plus 8 over 5 minus 1 into a one-line calculator entry. The entire numerator is a group, so begin with an opening parenthesis, 12 plus 8, and a closing parenthesis. Press divide. The entire denominator is another group, so enter an opening parenthesis, 5 minus 1, and a closing parenthesis. Now evaluate. The groups become 20 divided by 4, and the display is 5. A quick inverse check multiplies 5 by 4 and returns the numerator 20. Negative bases need careful keys. If x equals negative 4 and you need x squared, substitute the value inside parentheses. Enter open parenthesis, negative 4, close parenthesis, squared. The result is positive 16. If you enter negative 4 squared without grouping, many calculators interpret the exponent first and leave the negative sign outside, producing negative 16. These are different expressions. Parentheses tell the calculator that negative 4, not just 4, is the complete base. Now enter 2 times the quantity 5 plus 3 squared minus 7. Make implied multiplication explicit. Type 2 times open parenthesis 5 plus 3, close parenthesis, squared minus 7. The group gives 8. 8 squared is 64. 2 times 64 is 128. And subtracting 7 gives 121. Estimate before trusting the display. 2 times 64 is 128, so an answer 7 less should be 121. A display still needs interpretation. 7 divided by 8 becomes 0.875, a value between 3/4 and 1. The square root of the quantity 25 plus 11 becomes the square root of 36, or 6. 4.8 times 10 cubed represents 4,800. 18% represents 18 divided by 100, or 0.18. In each case, connect the screen back to size and meaning. Correct-looking display can still come from the wrong entry. A learner intends to divide the quantity 20 minus 8 by 4, but enters 20 minus 8 divided by 4. The calculator follows that entry and divides 8 by 4 first, giving 20 minus 2, or 18. The intended fraction needs parentheses around the numerator. Enter the quantity 20 minus 8 divided by 4. The group subtraction gives 12, and 12 divided by 4 is 3. The first wrong step was not arithmetic. It was the missing pair of parentheses that changed the expression before calculation began. Use this entry routine. First, identify every complete group. Second, add explicit multiplication and protect negative bases. Third, match parentheses and radical boundaries on the display. Fourth, estimate before pressing enter, then compare the result with that estimate. Final challenge. Enter the quantity 15 minus 3 squared divided by 6. Parenthesize 15 minus 3, square the completed group, then divide by 6. 12 squared is 144, and 144 divided by 6 is 24. The display should be 24.